Hi everyone. Thanks for listening to my final project presentation. I want to pause and thank you all for your feedback on my project. It gave me several factors to consider that helped me ask some compelling questions. The purpose of my final project is to analyze the land cover change of the Eagle Rock Resort and Humboldt Industrial Park in northeast Pennsylvania. The land was once rural forested hills and low mountains, but the development of the resort and industrial park has cleared the land for several impervious surfaces. I want to understand how much forest has been replaced. As a secondary goal, I would like to compare the simplest method of classification we experimented with, unsupervised in ArcGIS Pro, to the more labor-intensive object-based classification in ArcGIS Pro and eCognition. I want to see how much more exact the results are with manual intervention. I was inspired during the Lesson 3 lab activity where we viewed time-lapse Landsat movies. Here is the area of interest in 1984, and the same area in 2022. You can see the new development of neighborhoods in the resort and the expansion of the industrial park. The area of interest is a bit large for the final product, so I will be clipping it down, likely to the area in red that includes a bit of both development projects. My original idea was to use Landsat 5 data for the older imagery and Landsat 8 or 9 data for the newer imagery, but given the lower resolution, I decided to look into NAPE imagery instead. It is available from 2004 to 2022 in my area of interest, so I don't expect the same level of land use change as 1984, but there should still be plenty of instances of development. Now that we've gone through Lesson 6 with change detection, I'm confident I can go through the process of segmentation, classification, and calculation of the total acreage to see where impervious surfaces have replaced forest. My original idea also included using LiDAR to find slope as shown in this screenshot, but I don't think that that's as important as land use change in my area of interest. Ultimately, I want to see how much forest has been cleared for development. I also stated that I'd like to run unsupervised classification in Google Earth Engine, but I'd like to dedicate my time using eCognition instead. It is a complicated software I'd like more experience with. I want to compare unsupervised classification in ArcGIS Pro, object-based classification in Pro, and object-based classification in eCognition. Basically taking the easiest method we've covered versus the most manually intensive to see how much of a difference there is. The primary data source I am going to use for this project is from the National Agriculture Imagery Program, or NAPE. The imagery is captured by aerial sensors during agricultural growth seasons in the continental US. In my area of interest, there is imagery from several different years, but I've identified 2019 and 2004 as my primary interests. This screenshot you see here is from the 2022 imagery. It is peculiar looking since the east part of the imagery seems to be from a different time of year. This could make it difficult to do object-based analysis and use NDVI, so I decided to use the much cleaner 2019 data instead. Here is a screenshot of the 2019 data taken with a near-color infrared sensor on August 5, 2019. The 4-band imagery is displayed in the 123 natural color combination. You can see this does not have the same issue with vegetation as the 2022 imagery. The coordinate system is in NAD83 UTM zone 18 north in meters. It has a 0.6 meter pixel resolution and a radiometric resolution of 8-bit. Here is a screenshot of the 2004 data taken with a color infrared imagery sensor on June 12, 2004. The 3-band imagery is displayed in the 123 combination, which is near infrared, red, and green. The coordinate system is also in NAD83 UTM zone 18 north in meters. It has a 1 meter pixel resolution and an 8-bit radiometric resolution. The company that captured this imagery is called Suredex. To incorporate an NDSM for my object-based classification, I will be using the PA-MAP LiDAR dataset downloaded directly from their web application, which provides the data in LAS format. Thankfully, the PA-MAP LiDAR program has extensive metadata that helps us understand the specifications of the LiDAR collection. The LiDAR data and aerial imagery for the PA-MAP project was collected by BAE Systems with several contractors. The AOI is located in Luzerne County, which is the isolated example of 2006 data in eastern Pennsylvania. The coordinate system of the data is in EPSG code 2271, which is NAD83 State Plane, Pennsylvania North in feet. This dataset also has a defined vertical coordinate system of NAVD88. The project was collected with LiDAR Quality 3, meaning it has a nominal average point spacing of 1.4 meters with a vertical error RMSE of 20 centimeters. Furthermore, the LiDAR was captured at a 43-degree field of view with a laser pulse rate of 40.6 kHz. While I haven't gone through the entire process of object-based segmentation and classification, I have played around with ArcGIS Pro. I was able to clip my imagery boundaries to a more manageable area of interest. The area of interest intersects two different NAPE imagery tiles, so I needed to create a mosaic dataset to combine, then clip the area of interest boundary. From here, I played around with a few different segmentation thresholds. This image shows spectral and spatial data at 10 with 20 pixels for the minimum segment size. The result is pretty decent, but the segmentation isn't quite as exact as I'd like near some of the impervious surfaces of the industrial park. Here is the same segmentation run on the 2004 imagery. The lack of development in the north and the lower resolution imagery makes the segmentation simpler. I'm actually quite happy with this, though the clouds in the top left-hand corner could pose a problem. Here is an NDSM that I have created using ArcGIS Pro. After downloading the LiDAR data from the PA Map program, I created a DEM and DSM, then used raster calculator to subtract the DEM from the DSM. The pop-up window shows the height of one of those buildings in feet. You can also see the ski resort and the roads of the Eagle Rock Resort neighborhood clearly visible in black at lower elevations than the trees that they are cut from. The two primary softwares I will use for this project is ArcGIS Pro and eCognition. As stated earlier, Google Earth Engine was of interest, but I think eCognition is more important for my development as a remote sensing analyst, and I can access Google Earth Engine at any time after this course. This is the basic workflow diagram for my project from the data acquisition and pre-processing step. I have completed all of these steps, so I have all the rasters I need to complete the change detection analysis. This is the basic workflow diagram for my unsupervised classification. This is the simplest method we have experimented with, so I wanted to see how accurate it would be. I have completed the isocluster unsupervised classification, but need to assign the classes to the most appropriate land use. For my project, the 5 land uses I am looking to class include water, forest, grass, buildings, and pavement. I am including roads in the pavement data because they are so similar, and in this case their separation doesn't contribute to the objective of the project. Here are the results of the unsupervised classification using 10 classes. I may increase this to try and improve the accuracy and granularity of those classes. 2004 is on the left and 2019 is on the right. The object-based classification will take the majority of the time during this final project. Similar to Lesson 6, I will be looking to use eCognition and ArcGIS Pro to produce the results. Since random trees was a more successful method than support vector machine, I will be using that for ArcGIS Pro. As shown earlier in the presentation, I am currently experimenting with segmentation. I'm not sure if others ran into this problem, but I found the NDSM in Lesson 6 to be unreliable in certain spots. When analyzing land cover change, two datasets designed to work with one another should be close in vintage. The LiDAR data I downloaded is from 2006, but the NAPE imagery is from 2004. While the terrain won't change much, there are instances of buildings like the one shown here in ArcGIS Pro that was built in between the two different data source captures. Not being aware of this can make classification more difficult. I knew this ahead of time, but in an effort to get as much land use change as possible and to create a more compelling data set, I made a fairly large area. The total area is a little over 11.5 square miles, which is quite large for high-resolution imagery like NAPE. The segmentation I've run so far clearly takes longer, but I'd like to forge ahead and see how it turns out. There is a chance I need to reduce my AOI further, but for now I'm prepared to wait longer for things to run. I have always liked story maps because of their ability to communicate complex spatial and geographic problems to a wider audience. The ability to interact with things like time sliders or swipe tools help visually demonstrate the conclusions of a study or project. That being said, story maps can take a really long time to make. My ultimate goal is to create one and use maps and screenshots to explain the process I went through and the ultimate conclusions the data produced. There will be tables with acreage and land use change as well. If I run out of time, I will pivot to a lab report style deliverable focused on the outcome of the process and a comparison between the three different classification methods used. Thank you for listening to my proposal, and again, I'm appreciative of your feedback and open to answering any questions about my project and looking forward to seeing all of yours. Have a great day.